friends, welcome again to another session where we'll be looking at hydrogen bonds. In the previous session, we looked at covalent bonds and ionic bonds. If you've not watched that previous session, please I advise you to go back and look at it and have an understanding. Then you proceed to looking at hydrogen bonds. Let's dive in and learn how a hydrogen bond is formed and what really is found in hydrogen bond. Okay, so we have a definition of hydrogen bond on board. Please follow through as we read this definition because it summarizes everything about hydrogen bond. Okay, we just have to show it physically on how it is happening. Okay, so hydrogen bond is the attractive force here, attractive force between the hydrogen attached to an electronegative atom, okay, of one molecule, okay, take note, one molecule and electronegative atom, okay, electronegative atom of a different molecule. So here we've got a lot of molecules, okay, which are hydrogen bonding here, okay. So to cement this or to understand this definition, we are going to look at how water forms hydrogen bonds. Okay, let's draw the water molecule here. So we have that. Okay. So we should understand that here we're not talking about these bonds here, no. Okay, so these bonds here are covalent bonds. Okay, so these are covalent bonds. Okay, so to understand that, let's go through these points so that we learn through critically what happens when water is forming hydrogen bonds, and we'll have the basic understanding of hydrogen bonds. Okay, so number one, we are saying oxygen is more electronegative than oxygen. So there, look at this. We are saying this oxygen, okay, is more electronegative than hydrogen. And I believe you've watched the previous video where we were talking about electronegativity and how we are calculating. We found out that this bond between this oxygen and the hydrogen is polar. It's polarized. Why? Because there is an equal sharing of electrons. Oxygen, it being a high electronegative, it is pulling electrons from this hydrogen, which means the electrons are spending much of their time on this part of the molecule, which is oxygen. Okay, so the pulling that happens here, okay, the pulling of these electrons towards oxygen, okay, results in partial charges of the elements involved in the bonding. Okay, so when this happens, oxygen possesses partial negative charge, negative positive charges, and hydrogen gains partial positive charge, and also that. This symbol simply means delta. Okay, means delta. All right, so now let's move. So this is what this point is. So an equal sharing of electrons, so that is just electrons, a negative charge electron, okay, which leads to regions of partial charges. Okay, so when there is that unequal sharing of electrons, there is that unequal partial charges that happens around these molecules, as we have indicated here. Okay. Now, point number 3, opposite charges attract. Let's stop there. Okay, let's stop there. So these opposite charges we're talking about are not these charges we're seeing here amongst this molecule. When you read through our definition, it says different molecules. So let's draw water molecules around this water molecule. So, okay, let's draw water molecules around. Okay, yes, okay, even there. Okay, right. So we know we have concluded that there are partial charges around these elements. Sorry, partial negative, partial positive, partial positive, partial negative, partial positive, partial positive, partial negative, partial positive, partial positive. Let's look at this statement and try to understand it. So we have opposite charges attract. So what do we mean here? Right. Okay, so let's look at the definition again so that we cement this understanding properly. Okay, so let's read through. A hydrogen bond is the attractive force between the hydrogen. So let's look at this hydrogen. Hydrogen attached to an electronegative atom. So this is an electronegative atom, oxygen. Okay, of one molecule. So one molecule. So meaning the whole of this molecule and electronegative atom of a different molecule. So we have, let's look at this molecule also here. So we have this hydrogen which is partially positive, and also we have the oxygen which is highly electronegative and it is partial negative. So the attraction between this hydrogen which is partially positive and the oxygen which is highly electronegative and has a partial negative charge attracts. That's the bond that we're talking about as hydrogen bond. So this attraction here that happens between the negative oxygen and the partial positive hydrogen attraction. So this bond that is between these two elements is what we are referring to as hydrogen bond. Well, I believe you have understood and are able to draw even the rest of the bonds or that form hydrogen bond around this water molecule. Okay, let's move to another. Let's look at that. So hydrogen of attached to the electronegative atom of one molecule. So we have also oxygen, highly electronegative. Okay, so here there is a bond that will form. Okay, so this is hydrogen bond. Next, we also have, so we can form a bond there. Next, we can also form a bond between these two molecules. Okay, so this here, this bond between the hydrogen attached to the highly electronegative atom which is oxygen bonded to the highly electronegative atom of this water molecule forms what we are calling hydrogen bond. So this is what we mean when we talk of hydrogen bond. Let's finish our statement here. Opposite charges attract. We've shown that they have attracted. Partial positive, partial negative, attract. Partial positive, partial negative, attract. Partial negative, partial positive, attract. Partial positive, partial negative, attract. So this is what we mean when we say opposite charges attract. So, and these interactions are called hydrogen bonds. Hydrogen bonds. Okay, alright. This is all about hydrogen bond. But before we call it a day, let's try to cement something about how these bonds form and the number of bonds that form. Okay, we just emphasize on the lone pairs. Okay, so I'll try to restart this. Okay, I'll start to redraw so that we see clearly what's happening. Okay, so we are putting another water molecule here. Okay, so we have water molecule there with two lone pairs. Okay, and we said partial positive, partial positive, partial negative, partial negative. Okay, let's draw other water molecules quickly so that we see clearly what happens. Okay, even here let's have another water molecule. Okay, in there let's have another water molecule. Then here let's have another water molecule. Okay, so partial positive, partial negative, partial negative, partial negative, partial negative, partial negative, partial negative, even there, partial positive, partial positive, partial positive, partial positive. Okay, so we must understand that on the oxygen batch of one molecule of water, we've got two lone pairs, and these lone pairs were only able to form two bonds. Okay, we have no any other extra, so there will be no need of another molecule coming to get attached to this oxygen molecule of this water molecule here. Okay, so we said this hydrogen bond will form that bond with the oxygen, and also that will form with these lone pairs. So this is done, no more molecule can come through here, but if it was to come like that, the water molecule, okay, to get attached to what is on this hydroxygen bond, well, oxygen that is here, okay, because it has got free lone pairs that are languishing around, so to get attached to that. Same happens here, okay, even here. Okay, so we must understand that water is able to form 4 hydrogen bonds. Okay, so we have 1, 2, 3, and 4. Okay, so this is what we can talk about hydrogen bonds and the lone pair. So please pay attention when drawing the bonds. Pay attention to the lone pairs. Okay, so this is what I have for you, and you can call it a day. Hope you have enjoyed. Bye bye.